So.
Well, thank you, Peter, for joining us. Welcome, ladies and gentlemen. We are live, and this promises to be a very interesting discussion. We have with us today Peter Rothman, who is editor of H+ magazine, an excellent publication, by the way, where he is looking for great articles about the future of technology, humanity, the mind, society, and human culture. Peter is an engineering and management professional with deep experience in the design, development, and launch of commercial software products, internet services, and other mission-critical systems. He is currently doing research into analysis and visualization of text for a consumer-facing application. He was previously chief scientist of a biometrics-based fraud prevention company. He led the development of Live365.com, one of the largest providers of streaming audio on the internet. He operated product development and engineering team for the global multi-million-dollar public software company MetaTools, or MetaCreations. He founded and operated a startup software company, raised capital, and negotiated eventual sale of company. He has designed and implemented cutting-edge software algorithms and technologies. Peter's specialties include biometrics, mathematics, streaming media, virtual reality, simulation, text analysis, data visualization, and artificial intelligence. And very relevant to the topic of our discussion today, Peter was an early developer of virtual reality technologies, including developing applications of virtual reality to financial visualization, and a concept for unencumbered infantry training using virtual reality for the U.S. Army. And clearly, this is one of the most eminently qualified guests we can have to address the central question of our discussion today: how can virtual worlds help us improve the physical world? So, Peter, let's start just getting some general thoughts from you on this question. What do you think are some of the key areas in which virtual worlds have improved our physical world and can continue to do so?
Right. Well, so it's been, my involvement's now been a couple of decades, and virtual reality really started out as a sort of a splinter from the whole field of simulation and training. So, and it really originates as a subfield of what was called visual simulation in the aerospace industry, and so that's certainly one of the real world applications. Sort of the first thing that people thought of doing was, well, hey, let's simulate some real thing like flying an airplane, and then we're going to use this as a training system to train pilots, or you can envision other kind of what they call task training systems to teach, like landing on, for a military application, landing on an aircraft carrier. It's a very difficult task. If you mess up, you might die. So you practice a lot in a simulator. So that was sort of the first thing that people thought of. But in the early '90s, there was this period that was sort of a virtual reality boom of sorts, or boomlet. There was a period where Jaron Lanier, who you may know who he is, or your audience may have heard of him, but he got a certain amount of attention, and he coined the term virtual reality for these kinds of systems. And in his vision, this visual simulation environment was combined with a head-mounted display and some sensors on your body that measured your position and head orientation, and then other sorts of interfaces like a glove that were sort of more. The notion was they were more natural interfaces. So that was the novelty of virtual reality. But no one really knew what to do with it. Initially, like, what is it good for? So there's some very early applications around that time, '93, '94, where people tried to find products that employed virtual reality. I mean, let me pull out a book just to show you that period. I thought I had it out, but I think I put it back. Well, I can't find it right this second. I'll find that book in a second. But it was a period of garage VR, And so, like, state-of-the-art thing that people might do at that time was use a Mattel Power Glove. It's a gaming interface, the Mattel Power Glove, you know, and people would hack these devices. That became the Data Glove. Here's a kind of a different idea that we pioneered, and it was a number of people around that same period got the idea that data visualization, which was kind of a nascent field at that time. I mean, it existed. There was not like 1990. People had done data visualizations and charting. Scientific graphing existed, of course. But here's a product. I don't know if you can see that. This is actually maybe a little bit better image. This is from the cover of a magazine. That's the product, and it's a view of the stock market in a 3D space. And it actually was packaged as a product. Here's a box. Software was today. This is a little strange. What is that? But they used to have software in stores, in boxes.
I remember that.
Store, and we would mail this to you, like if you bought it. That was pre-internet, and here's like our marketing literature. So this was like an early idea that was you would view information in a virtual reality system. And then some other ideas were put forward, splintering off the training. There was sort of the military training, but then there's a lot of commercial training things that people wanted to do. So, for example, some people worked on firefighter training. That's sort of a natural follow-on to like our infantry training work. And there's, of course, driving simulators for rail operators. So that's kind of like flight simulation, but I don't know how far. There's not so many rail operators anymore. So there's other things, and medical applications were developed. There's a fellow, Walter Greenleaf, and he was a pioneer of that, and he used the gloves to measure dynamics of the hand, for example. Instead of just using it as an interface, he used it as a medical device, to measure something that's going on with their hand. And then he also was interested, and there's a fellow from the military, Colonel Satava was his name. I don't know what he's up to these days, but he was a surgeon, and they were very interested in surgical training, which is kind of a radical departure from the sorts of trainers that people were building before that. So that was but still training and simulation. So you had training and simulation, data visualization, and sort of the third main thrust, which is what really is left of all of that in some sense, was entertainment. Entertainment ate virtual reality in a very real way from at least the early phase of virtual reality. Business became video games. But in the early days, we were doing things like location-based entertainment systems. So VR systems were pretty large and expensive if they were any good. And you needed like a $30,000 workstation or something or up to do good VR. A Silicon Graphics computer, for example, could cost hundreds of thousands to millions of dollars. So this was not something that was like a home system, right? So people would put these in arcades, a $75,000 like arcade system with a head-mounted display. A company, Virtuality, out of the UK, built a system like that. It was probably the best one. Or the most successful in the marketplace. My company did a little work in that area, and then some other applications that were interesting, but in the early days just never went very far for various reasons you could debate. But design. So this is the fourth kind of major application area, which is industrial design. Sort of seemed obvious, like. And actually, one of the earliest companies to pioneer tools for virtual reality was Autodesk, the makers of AutoCAD, and they're obviously in computer-aided design, and they saw virtual reality as sort of just an extension of what they're already doing, particularly for architectural design. But not just architecture of buildings, but objects, physical objects. You could create them in virtual reality and look at them, or experience them that way. We did some work for the Army, and there was various people that were doing like vehicle simulations in VR. So you could have a not really for training now, but for user interface and displays and controls design projects, you don't want to build like a physical prototype. It's very expensive. You want to like experiment with it first, and then only then take it to physical. And so there were a variety of tools that were used for building such display interfaces, and some people wanted to do that in VR. We had a project to do that. Those are pretty much the four main application areas. So simulation training, that's the start. Data visualization, entertainment, and design. Those are, and there's a few others, but you might, there are weird ideas that maybe they don't fit into any of the four categories. But there you go.
So thank you for that excellent overview of the evolution of virtual reality technologies and how they have been applied to date. Now, I'm curious with regard to your thoughts about changes in the cost and the reductions in cost in the recent few years leading to such developments as the Oculus Rift, which might perhaps render these technologies available to a broader consumer base. Do you see a paradigm shift in how virtual reality is going to be used in the next few years as a result of this?
Yeah, it's not just cost, though. There's a couple of different things going on. One of them is obviously cost. But at the same time, you have a quality improvement. Like if you didn't have that, if it was just the same devices we had in the 90s and it was cheaper, that wouldn't be enough. And there were several people in the 90s that produced such devices, but they failed in the market. So quality plus cost plus a different world. We live in a different world. What's different about it? Well, we're living in the future. I mean, really, like wireless device, pervasive wireless technology, broadband wireless devices enable something like what Google did with their cardboard VR display thing. And you can debate the merits of that whole project or whatever, but it's interesting. Whatever. It was intended maybe to be a slap in the face to Facebook or something. After they bought Oculus, I don't really know, but I mean, the point is that's a big change from what now that everyone has like a little supercomputer with a wireless and high resolution color display built into it. That didn't exist. So that changes a lot of things. And then you have, I mean, just the pervasive internet, ubiquitous internet, and I mentioned it earlier, the delivery of software. Here's another product. This box is kind of falling apart, but this is Bryce. And Bryce was a MetaCreations, MetaTools product that sort of absorbed my entire VR company into it. It became one button in that product, actually. but sad but true. But that that is a whole other. That's like a design tool that uses virtual reality for preview, right? So we used to sell software in these boxes. So now you have this world where data and you can have high bandwidth streaming media to virtual reality systems. That changes everything. It's a whole different world. So that's another factor. Just this ubiquitous infrastructure for doing all sorts of things that didn't exist. And I just think we're collectively, you and me, and probably a lot of your viewers, just more used to the idea. We're online so much. Virtual reality is less of a step from Facebook than it was from zero. Like in the 90s, what we were talking about is, you're using, I mean, there's people still using MS-DOS, okay. So, and they preferred it, right? They didn't want to switch to Windows. I remember talking to people like, around that period. And just to put that in perspective, this product we made, VR Trader, ran on Windows 3.1 originally, and then 95 and 98 later. So that's how early that was. And at that time, people, we also had an MS-DOS-based system because some people wanted that. And you could do some things, actually, from there that you didn't really need Windows if you're going to run a virtual reality system. So, Oculus, let's talk about that, because you asked specifically about them. They have a pretty nice head-mounted display for a low cost. But does it really change everything? I'm going to say no. If you don't have these other ingredients, it wouldn't have changed everything. But when you put it all together, then it does. Second, you know, I don't know that they have something that's unassailable as a competitive advantage, just as their product. You know, that the specific display is good, but back in the 90s, we call that kind of design a face sucker. I'm going to pull out a different. I had this here. I was tempted to wear this right from the beginning of the show here, but I decided against that because it looks kind of goofy when you have. That's the thing about VR. I mean, one thing that people haven't talked about is the fashion factor, because it's not really too fashionable. You look like an idiot, you know, with an Oculus stuck on your face. You're like an alien, right? And a lot of people have forgotten, or the information is lost from the 1990s era that, for example, a lot of people, a lot of women wouldn't put the head-mounted displays on in those days because they were at a trade show, we were showing them equipment, and they had their hair done. And there's no way, right? Like, and they're not. You put that thing on, and you have. Well, look at this, right? If I had any kind of hair, which I don't, because it's an advantage if you're doing VR research to be bald. See, but if you have hair, you're going to put this on. It's going to mess up your hairstyle. This is a 90s era VR display, but I still have. It works, and it's a flip up like this, and this is kind of more of an industrial thing, right? Like you would use this for a business application, and this is the kind of thing that we want to use for some military applications, but it's perhaps not very fashionable. But you can see the distinction from that design from what Oculus has. What Oculus has is, you know, stuck onto your face. We call those face suckers. The earliest VR displays that I ever saw were of that variety. And now a lot of people at the time were derisive towards us. It was a negative. We call it a face sucker. That's an insult. Why? Because the thing's stuck on your face, like kind of pressing on your face, and it was uncomfortable. Now, Oculus has improved on some of that stuff, but if you wear this device for any period of time, like so we were interested in long periods of immersion. That was one of the experimental areas I was personally interested in. I did a lot of home experimentation, you know, on this personally. And you know what happens if you wear a display for 3 or 4 or 5 hours? You know, first of all, you're gonna get a headache probably, but like I mean, it's just uncomfortable. And there's things that you don't notice if you just put it on in a demo for 5 or 10 minutes. Right, like it's heavy on your face, and you get a rash, right? You know, because it's this. So what's that material that's coming in contact with your skin? So these things people don't appreciate till you like actually try and to do some kind of crazy self-experimentation, like wearing the thing for 2 or 3 days. And you don't want to do that. I not with any device that's out. I mean, I know someone that did it actually. That a friend of mine that I met fairly recently. He is doing something out of San Francisco called the Outer Body Experience, and it's a telepresence experiment. But he's an artist and a software developer, Jason Wilson, and what he did with I guess another fellow is they as an art project, and it just led to what he's doing now. But they lived in telepresence for 3 days in like a gallery.
Oh wow!
And they couldn't see. They couldn't see. They had a device like kind of similar to this, and then there was cameras, so they saw everything from a third-person perspective, and they lived that way for 3 days. And you know, they didn't have full coverage of the room, so like people could sneak in and do stuff when they couldn't see, things like that. So it's quite an interesting little experiment. And there's some more recent experiments where people are doing telepresence is a little bit different than virtual reality, right? So maybe we can talk about that too. But so anyway, I'm skeptical of Oculus and that design.
Now, do you think from a practical perspective, something more along the lines of augmented reality. Say a Microsoft's HoloLens is more likely to take hold just because it leaves one, let's say, more connected with the external world. The device is not as cumbersome to wear, perhaps not as constraining. Of course, I would have used Google Glass as an example had it fared better than it actually did. But I could conceptually say something similar about Google Glass. It would seem to be a device that would have a greater chance of public acceptance from a comfort and aesthetic standpoint.
Well, they tried on the aesthetics, but I guess that it depends on the aesthetics is and fashion. Now you're getting into fashion, and it's a very interesting thing. And fashion is a technology, so people don't always appreciate that. When done right, it's a technology, and I know a few people would get it, but the thing is, they tried to bring it as fashion, and they actually did a fashion show where they, shot from the stage perspective, and I forget the designer that they worked with now, but so they tried, but it's you can't, fashion is its own kind of technology, and you have to be a fashion genius to create a new genius fashion trend, and they missed. Right, I mean, that's all. I mean, fashion is notorious for misses. You don't hear about them so much. You hear about the hits. But there's lots of failed fashion designers, and bad fashion and ugly clothes. So, we might disagree about what's ugly, right? And Google Glass was a one-size-fits-all kind of thing. And that is, in my view, now we're getting into wearables a little bit, but I don't think that's the future of wearables at all. One-size-fits-all, that doesn't make any sense. You and I are dressed differently because we're different people. That's okay. Like we wouldn't wear the same display for the same reasons. I mean, that's all. It doesn't. The idea that some uniformity is going to take hold is nonsensical. So even look at phones. People modify their phones. I know I see them all the time with bejeweled and crazy things hanging off of them, and then what you put on it is part of that. So anyway, I think they missed a little bit on the fashion, but I'm not sure exactly what the missed ingredients are with Google Glass, but it became associated with kind of this asshole person that used it in the wrong place at the wrong time, and that kind of paradigm and of thought took hold, and so it's hard to overcome that kind of social stigma once it happens. But augmented reality, more generally, besides Google Glass, is a much more powerful concept than what was implemented in Glass. Glass was a monocular display of low resolution, relatively low resolution. What the HoloLens, Microsoft put forward, and they're not the only company developing it. There's a mysterious San Francisco startup, Magic Leap, you might know of or heard of them, but that's another outfit that's going in the same kind of direction. What they're trying to do is a stereoscopic display of extreme high fidelity. So, how far can you actually achieve the promise of this idea? I don't know. When you actually put it on, a few people and I haven't been fortunate enough to try it, but people that have say, it's astounding. Okay, that's a reaction. But in theory, this sort of display, a light field display, a stereoscopic light field display, can insert photorealistic objects into your physical environment such that they appear real. I mean, you can't distinguish them merely by looking at them. That's, I would say, theoretically plausible and possible in reality. Now, will you really not be able to tell? I mean, there might be some glitches, I don't know. But it's going to be pretty close. Magic Leap has this little, it's fake, but they have this little demo or image, and someone's holding their hands, and there's like what appears to be a very small but photorealistic elephant in the hands, right? So these are the kinds of things that you can imagine. Now, Microsoft, and I guess I should plug a couple of my own articles here, but I wrote a recent article about this whole HoloLens release and what I call mixed reality, and I didn't coin that term, but it's, I believe, the correct term. I'll talk a little bit more about that in a minute. But I'll just, on H Plus Magazine, if you look up mixed reality, that article's there. And I also wrote an article, just stepping back a bit, on called Retro VR, that covers the head-mounted display and face suckers, and it's a little bit snarky, but there it is. But anyway, so check out those two articles. But
yes, I will share them with my viewers as well. When I finalize the description of this event, I will include links to those articles on my YouTube channel.
Great. So anyway, so HoloLens, in their demo video, which I think captures the vision of mixed reality and its potential quite impressively, and Microsoft is sort of back. And when I saw that, that was what came to me. I was like, wow, you know, they're like back in the game. I actually know some people that are up there that I think are very smart people, so I'm happy to see this kind of vision coming out of Microsoft. But the HoloLens takes that, and you know, the demo video they showed shows you know, a deep integration of virtual objects and real physical objects. So, for example, a virtual chess site would appear on your table, and you could play against another real person wearing the same kind of display, or against a person who's not there but is somewhere else, also wearing one in their home. Either way, it'll work. This is creating a situation which we would correctly call mixed reality, or inter-reality sometimes in the literature it's referred to. And it's really a big deal. It seems like not a big deal. Like augmented reality started, and I don't use that term because to me that's more like the Google Glass. I'm going to talk about mixed reality, and I'm going to distinguish the two in a second. But augmented reality started out as sort of this toy, this marketing toy. Like you get a magazine and it would have some sort of like a QR symbol or some kind of code on it. There's various schemes, and then if you had your phone or your tablet, you would point a camera at it, and you know, you would see a little character dance or do something stupid. I mean, generally, I say stupid because every single example I saw was stupid. Now, maybe somebody did something cool, but I never saw it. And it's kind of a surprising effect once. It's a gimmick, right? But mixed reality is not a gimmick. Mixed reality is something that where it goes right to the topic, you know, of this conversation, which is what's the connection between virtual reality and real reality? And what mixed reality is this state that an object can be in where it exists in both the virtual and physical realms. So slowly and quietly, you know, since the 90s, we've built this pervasive infrastructure I was talking about earlier, where we have a lot of stuff that's like that. All kinds of things that exist in this kind of digital realm, and at the same time they're physical objects, and the two different things interact. And I have to say something about what that means. Like, so it means that the behavior of the system can't be predicted by looking at one or the other alone. You can't know what's going to happen to the temperature in your house unless I know the temperature, the actual physical measurements, but I also have to know something about what's happening in this digital control system that's controlling it. If I don't know those two things, I really can't predict what's going to happen. So that your house, if you have a digital control thermostat, kind of exists already in this mixed reality state. But nobody noticed, right? Like that happened. The world didn't change, or did it? You know, so now we're going into something a little bit deeper, where I mean, so some recent experiments, and I'm sorry I'm blanking on the fellow's name. Maybe it'll come to me at some random moment. But he did some experiments with a pendulum. Okay, now this is kind of a commonly employed physical apparatus that every high school physics student would encounter, or maybe even younger, hopefully. And it's a weight on the end of a string, and it swings back and forth. Okay.
Is that the Newton's cradle?
Yeah, I mean, it's the most basic kind of, exactly, right? It's the most basic kind of physical machine, or one of the most basic machines you can imagine, is a pendulum. Mechanical device, simple, complicated dynamics when you start considering all the possible things about it. But and I studied mechanics in college, and that like and there's wind and there's friction, right? So, but a pendulum's not really that simple. But the most simplistic model of it is kind of simple, and so it's kind of natural to create a virtual reality pendulum. So what this guy did is he and some people had done, I didn't actually talk about this, but it's kind of a variant of training, which is, you could do like, some people have done a virtual physics lab. That's a simple thing to do, and it's useful for like a high school situation where you can have a virtual reality, you can have a lot of experiments that you couldn't have actually in your high school in this virtual lab.
Oh yes, I remember actually doing various science labs in high school, physics labs, chemistry labs, biology labs, and I was thinking, yes, it's possible to use these to illustrate the essential concepts that the lab was designed to teach, whether it be to see a particular law of physics in action or look at a biological structure, but the real world in which these experiments were conducted was often messy, and there was a huge possibility of error. And I was thinking at the time, if you turn this into a virtual lab where you can do, say, a virtual dissection or, say, a virtual experiment with an object on an inclined plane, you wouldn't have these messy, complicating factors. You could see the ideas a lot better.
Yeah, I mean, in some cases it's cleaner presentation. In other cases, that opens some maybe areas for doubt. Like, I mean, there's no surprise. You can't have scientific surprise in a simulation, maybe. Like, you see what I'm saying? Like, it's predetermined what can happen in the simulation, but does that simulation really map to the physical world that you're trying to understand, where you might be surprised by some phenomenon you didn't know about? That can't happen in a simulation you build to represent, there's no surprise. Oh, that's a deep topic for another day, maybe. But and there is a problem more generally in simulation training when you have a divergence of the simulation from the real world of negative training. This is a big thing that the military was worried about, and I was personally worried about, and I wrote a whole bunch of stuff about, which is, if the system doesn't really represent the real world and you're using it to train a person, then what they learn might not be what you want them to learn. If it's a military application, we work with the Army, and I might get somebody killed. So, negative training is the terminology, and it's hard to know. It's a very subtle phenomenon, negative training. It's hard to predict, like, as a designer, that this is going to occur in your trainer. Like, if training system designers could avoid negative training scenarios by design, they would, but they fail to do so frequently and over again, despite there being books written about this and stuff. So, yeah, education is going to be huge.
Mm-hmm. Yes, I was thinking of using the mixed reality model within the classroom, and that could have so many advantages. You could save on costs of materials, and you could also really immerse students in the subject being taught a lot better. If instead of learning, say, art history from books, you can actually see the full-scale painting that is being discussed right in front of you. That would, I think, really trigger a lot of people's interests. And one area of discussion that I wanted to touch a bit more on is the combination of entertainment and education, or entertainment and behavior for improving the world. It does seem to me, as you pointed out, a lot of applications of virtual reality have been for entertainment, and that's been the case also with, say, computer games, video games, a lot of the emerging technologies we've seen over the past few decades, and those can be hugely addictive to people. What if somebody figures out ways to harness that addictive quality and channel it into very constructive behaviors?
Well, I mean, there's this whole, there's games for good, there's this notion of gamification, there's all kinds of ideas of using game design principles to get people to do things that are good. So that's one thrust. But another thrust is, I mentioned negative training, but with that said, what can you do to build virtual education environments that are optimal or actually provably, demonstratably improve learning? And there are some results. Actually, my wife, I'll give her a plug. My wife is who is at the Stanford Business School, and they have launched something called the LEED certificate, and they are doing some pretty cutting-edge virtual reality stuff where the participants in this business education executive program for it's an online education program for executives, and it's going to in part be conducted in virtual reality, so. There's some folks at Stanford that they have some research and that has to do with things like like gaze. When you learn better when the teacher looks at you, right? So there's all kinds of results about learning and how people learn in a social environment. You learn better in a classroom with other people. I took remote in the 1980s, just to age myself a little bit. I took graduate classes remotely by cable television, and when we wanted to call into the or talk to the teacher, we would call up on the telephone, and it was like the old dial phone. You know? I mean, really, it was that archaic. But so we had cable. We'd see the class on cable TV, and then we would call up, and that's how we interacted. But there was a couple of us that sat in this room, and so we kind of interacted. But learning now with a lot of the online MOOCs and so forth, the learner is sitting in a room by themselves, and it just is not very effective for various different reasons. And there's research about, what makes people learn and what are good learning environments. And so some of that has been replicated, or variants of those ideas have been replicated now in virtual learning environments. So can you, for example, have the teacher's avatar can do things that the physical teacher can't do. Like a physical teacher can only look at one student. I mean, I'm looking at you, and then I have to look over here, and then but the avatar it could be different to each student. One of the interesting things about virtual reality that people forgot between the 1990s and today is that it's magic. Right? Anything can happen. Anything can happen. Really, I see this in some of the apps that I'm seeing, or the applications and the games that people are doing and the things I'm coming out. They forgot the magic. They lost that idea. There's a number of ideas that got lost with us old timers from the early days. And one of them is this: don't forget the magic. I mean, the professor can look at everybody. Each avatar of the professor will engage each student in the most effective manner scientifically known. Yes. So, and further, you can, the students themselves can appear differently to different people, but that's a whole separate social design issue that I'm not going to delve into too much. But there's lots of things known about what makes people learn, and virtual reality is one piece of maybe what we might envision as a hyper-effective learning machine of the future. We don't have that today, but there's definitely some people out there doing that. Now, games themselves, there's games that can. Game design is fascinating. I'm actually designing a game. I was a gamer from way back, of course. Like a lot of people that are involved with computers and virtual reality. I mean, you come at it from maybe even like board gaming or computer gaming, video games. Virtual reality in the 90s then sort of became the modern video, 3D first-person shooter video game. A lot of people don't know that. I mean, before the 1990s era, video games were largely 2D. And the devices, the actual physical chips that people were using, the chipsets people were using, were not well adapted to producing 3D computer graphics. And there were some game designers that did workarounds and notable, kinds of tricks to, get 3D worlds into a machine that wasn't really intended to do it. Like there was a game, one of my favorite games, Battlezone from that era, was like a 3D line, a vector rendering approach. But you really couldn't do what we would consider 3D, in those days. There was in the early virtual reality business, Jaron Lanier, I mentioned earlier, started this company. It's called VPL, and one of the fellows that worked at VPL, his name is George Zachary. He went and worked at Silicon Graphics after VPL, and then Silicon Graphics worked with Nintendo, and they built the first truly 3D console video game system. If it wasn't for George, who I don't know particularly well, but I'm going to give him the credit. I mean, he's the person that saved virtual reality, and it became video games through him, and that led to today when we could have things like the Oculus reappear and be credible again. So games have a big role in the history of virtual reality for sure. Beyond that, you have this games for good idea. Like, what if you had a game where you rescue people and actually you are rescuing them?
Yes.
I mean, like, what if it's like an emergency and it's like a game interface, but like it's actually drones and you're bringing them the supplies? What? I mean, imagination is the limit with virtual reality. That's why I'm talking about the magic. And there's this one book that I found. I recently had a personal disaster where some of my archives were destroyed.
Oh, that's terrible.
Yeah, but I don't want to talk about that. I want to show you this book if I can find it. Because it wasn't destroyed. And I was super happy that it wasn't destroyed. I thought I put it out just to show you, and I don't see what I did with it. Okay, well, I'll find it and I will scan some images and I will send them to you to include in the links. But it's a wonderful little book called Virtual Reality for Dummies, or Virtual Reality Design for Dummies, something like that. And it's basically a hand-drawn. This woman did it, and it's all like hand-drawn figures and written out by hand. It's kind of crazy. But she makes the point in there that virtual reality worlds don't have to obey physical laws. They can incorporate what would normally be called magical principles. Like, for example, Doctor Who, his famous space-time ship, the TARDIS, can is bigger inside than it is outside. Well, in virtual reality, that's completely possible. You can do that all the time. That's like an old trick. What's inside is much bigger than you can have a doorway that opens into a whole world. Ordinary objects can become non-ordinary. A flower can be a control interface, and say the petals represent files on your hard drive, and as they fall to the floor, they're deleted. You have one last chance to catch it before it's finally erased. I mean, whatever you imagine can be done. That's the thing about it. Which brings me full circle back to this thing about mixed reality. So what the HoloLens represents is this sort of profound shift that already happened, really, where we entered a world where the physical and virtual worlds are intimately connected and cannot be disconnected. We can't predict one without understanding the other anymore. We're all in this world, and it's going to become through technologies like HoloLens or Leap, when we ever get to see one. This is going to be made visually present in our world. Like, it's not just going to be like your thermostat anymore. It's going to be dancing fairies on your bringing you information. Whatever you want can happen and be presented to you as real, or as real as you choose it to be, cartoony or whatever. So it opens some pretty interesting possibilities. I mean, educating ourselves as one, immersing ourselves in a world of illusion that we never leave is, maybe a negative dystopian kind of view of it.
Yes. So I'm curious as to your view of which one of these will prevail or at least predominate. I could understand, of course, a lot of people doing a bit of both, just like a lot of people will play computer games purely for entertainment today, and you could say it builds certain skills or it's a form of art that they enjoy, but then also they use computer technology to accomplish a lot of work too. So do you think the vast majority of people will do something along those lines, a hybrid approach, or are you concerned that a lot of people, if this technology progresses to the point where it's very high fidelity, very realistic, a lot of people will just decide to stay in those worlds?
Yeah. Well, I don't know how many people are going to decide to stay in those worlds, that are just mere illusion. Because one of the things that's going to happen is our physical world is going to become hyper, real in a sense, where because as I said, it's got this virtual world is going to become visually present in your real world. It's not the distinction will become less and less meaningful in some way, and it's up to us to make sure it's the right way. I mean, that's you can imagine a maladaptive world where we immerse ourselves in this virtual environment and it's just a mere illusion and we forget to feed ourselves and we'll starve to death. I mean, you can imagine things like that. Or you can say, well, I'm going to live in this informated world where I can know anything about any object that I cast my gaze on. I can get information of the world from anywhere. I can, instead of having computer displays, and using all of the mineral resources and so on to produce. I mean, I have a display here. I've got the one I'm looking at. I've got a phone. I've got how many of these things I have. Instead of that, I would have a pair of glasses. Displays would be anywhere I looked. So I think that's it's probably a good idea just in terms of how we currently use things like. We don't need all these displays. We need a really good pair of glasses. Now, I haven't tried HoloLens and I haven't tried Leap, so I can't say if they're really good. But in concept, I think that's the way it's going to go. I mean, really, the HoloLens doesn't quite get there on fashion, and there's some physical limitations I understand in the technology that might mean it has to kind of stay big. But I don't know enough about it.
So, and here's an interesting question. The technologies we've discussed are really on the cutting edge right now. They're not yet in the hands of the majority of consumers. And you have been discussing a cultural shift that has taken place since the 1990s, where through exposure to a lot more technology, to the internet, to video games, to computer games, people today are more accepting of even the Oculus Rift, but certainly of the HoloLens than they would have been back then. Do you think this acceptance has reached a critical mass yet, to the point where if it were out in stores and hypothetically the majority of consumers had the resources to purchase a HoloLens, would they do that?
Well, HoloLens versus Oculus, I might come up with a different answer. I mean, in the end, it depends on what you can do with it. You have to see the applications. I've shipped I've shipped a number of different kinds of products. I must have been in the software business, as it turns out, my whole adult life, and I've shipped a number of different commercial products. Software. I showed you some packaged software products that I helped ship, where I led the shipping over various roles, and I've shipped Live 365 was an online web service that we built from the ground up, from 0 to 1 million people. When I was there, and it's hard to say what's going to make a successful consumer product. It's a black art. I don't even know. Like, I participated in the building of successful products, and there's a certain amount of. I used to work with this pretty well-known guy, Kai Krause. He used to call it pixie dust, but there's something that is. Some of us have the skill of helping products find it, the greatness that lies within. I would like to think I'm good at helping people find that in their products, and I do that sometimes professionally as a consultant. Like, I help other people get greatness. But how do I do it? I'm not sure I totally understand it. I really, frankly, don't. It's almost pixie dust, and it takes just a lot of thinking and time, and sometimes it happens as you're kind of going late at night or whatever, or unexpected moments. You're having dinner, or you're whatever, you're doing something else, and then that's when you find the thing that makes something great. So I don't see that in. I gotta say, Oculus. I don't see this. I don't see it. It's not there yet. I haven't seen Facebook's apps. I'm waiting to see what they're building. I hear that they're building a lot of stuff. So one thing I heard was promising to me, which is this notion of a virtual reality operating system. It's something my company tried to develop a long time ago. We called ours Amber C++, and it had a lot of it's a virtual reality toolkit that had a lot of operating system and task scheduling elements to it. And so I heard Facebook was doing something like that, and I think that's kind of interesting. And the whole question of what if you imagine sort of the standard productivity applications and social applications people are using today, if you imagine those in a virtual world, there's a whole question of what the user interface and controls and displays for such a system look like in virtual worlds. Like, it could just be a desktop floating in space, but my God, I think we could do better, than that. Mm-hmm. My company did a lot of crazy things. We were early experimenters, so we did things like, we had a giant red button. It's like, it looks like you're going to launch a nuclear missile, and it would open up and click. That's how you would close your window, like that kind of thing. So you can do anything you want, or like the flower example I gave earlier. That we had a flower, a picker that was a flower. Like, instead of radio buttons, you could have, anything goes. That's the thing that people that are, my words of wisdom to any virtual reality designers that are watching this today that are new into in modern era of virtual reality. If you want to learn anything from what went before, it's just go back to that magic and don't get caught up in what's real. And people are trying to create realistic images and hyper-realistic images, and sometimes what makes something amazing in this realm is where it breaks from reality, not where it captures it.
And it's interesting. I can see how that kind of thinking can also inspire some people to innovate in the physical world as well, just because the structures that currently exist in our physical world may sometimes be a creation of societal convention rather than something dictated by the laws of nature. And if people have that habit of mental flexibility, the application of imagination to create new structures, new designs, that could spill over into the physical world. Perhaps another way in which working in virtual worlds can help improve the physical world. So my last question for you, Peter, today is, as a techno-optimist, I would like to see a faster pace of development of mixed reality, virtual reality, essentially the integration of emerging technologies with our world for the improvement of human well-being. What actions can people take, and not just people who work in this space, but most anybody watching our discussion today, to help speed things along, to help accelerate progress in these areas, to help people accept these technologies a bit more?
Commercial devices today, and you can, even if you're not a software developer, you can get some experience with virtual. I mean, it's something that people don't today, even though the devices are much less expensive and widely available. A lot of people don't actually have the experience of having tried virtual reality, and it is something that when you try a really good VR system, and the world and the display and the tracker, and it's all done correctly, which is, we didn't talk about this, but it's not all about, you can have a good display and you can have some crappy software, and you'll want to vomit. I can make you vomit in about 30 seconds by design, right? I mean, I can design a system that does that. So it's actually used in the old days, it was kind of hard to avoid. just because of lag and latency. And low frame rates, things like this would make people nauseous. But so, you know, how can people make this happen if they're not software developers? Well, but if you're a creative person, there's all kinds of elements that you can get into. Of course, in something like Second Life, a lot of people are creating objects, 3D objects, and sharing them and selling them. There's a whole business in that, for better or worse. You can create virtual objects. It just does. Anybody can do it. You get downloaded tools, start doing it. Some people are better at it than others. If you want to support, if all you want to do is support, then buy stuff like that. You can support by supporting the people that are doing the research, by crowdfunding efforts. There's a number of interesting people doing crowdfunding for display technologies. Support those. If you see something that's interesting. HoloLens, of course, you can't crowdfund. That's a Microsoft product. So, I don't know. They're not looking for crowdfunding. But maybe they will in the future. I think there's a lot of things that are developers can do. There's wide open spaces. If you are a coder and you don't know anything about virtual reality, it's wide open to learn and get Unity, download it, start coding. I didn't talk too much about it in this thing. There's so many things to talk about, but there's the whole WebGL and Web 3D movement, sort of the heirs to Vermal. If you know what VRML, Vermal was a Web 3D markup language that was created in the 1990s era, and then it sort of fizzled out with virtual reality itself, but it's been around. There's a number of people that have kept working on it, and they just stuck to it all this time. And I'll just mention Tony Parisi, who's a friend of mine, and a great guy who's stuck with that all of these years and is, the world's expert on that. And so WebGL, check that out. But there's just a lot of people that have been sticking with these things for many years. So it's nice to see it all come to fruition again. And it's time. I predicted this many years ago, actually, that 2015 was going to be the year that virtual reality would return. So I'm sticking to my guns. I made that prediction at an SRI conference on virtual reality, sort of at the beginning of the so-called virtual reality winter, when the boom died out, and it was based on studying some patents that were expired. So here we are in 2015, and that prediction looks pretty good.
Excellent. Well, it's an exciting time to be alive, certainly, and to witness the progress of these technologies, which I hope will seep into the mainstream, or perhaps flow at a massive rate into the mainstream to help improve the lives of really as many people as possible. So, Peter, we're very happy to have you today for this discussion. Certainly, you touched on an immensely broad array of ideas, and I will be able to share with my viewers any references that you would like to provide afterward, because I think there's tremendous potential for study in this area, and perhaps that will motivate more of my viewers to make some contributions. So thank you very much, Peter.
You're welcome, and we definitely share that objective. So thank you for having me on.
Indeed. Farewell.